Let me talk today about some of the cool things that happened on the Amadeus Rust node rewrite, because quite a few things changed. And without further ado, let's go to the terminal and try running the node. And it is as simple as just doing cargo node, right? And this uses an alias, this one. So it runs the package client binary node. And now the node and CLI examples are organized as binaries. Because we started it without the Rust log environment variable, it doesn't print anything, but it has it is working. It has the dashboard running. And as you can see here on the new dashboard, it already handshaked with peers since we started it. And you can also see here the messages that went out and into the node, and also the list of peers. And you can even sort them by clicking. Let's, for example, sort by the block height, like this. It also fetched the versions. The latency part is not implemented yet because latency is derived from the PONG message, and PONG message requires ping message to be accepted, and ping message needs the correct and valid entries to be accepted and processed on the peer side. So I'm working on that right now. Among other cards, we have this peer nodes card, which is just the summary, the network input output that got improved a lot. So now it's much more easy to read. It has this system card that has the tasks and errors. Errors is the counter of errors that happened inside the node. The tasks is the current counter of parallel tasks, because when messages are arriving more or less at the same time, they can be handled in parallel. So for that, a few parallel tasks are created to handle messages in parallel. The CPU usage and memory usage are working well right now. The disk usage is just the mock disk usage. It's not implemented yet, but it will be implemented a bit later. You can also copy your key. This is the public key of the current node. So that's about the dashboard. And if you go back to the cargo node, we can restart it with Rust log environment variable to see what the node is dumping into logs. And here we see some of the basic information, like where it is working, key that it started both UDP and HTTP servers, and started sending handshake initiation requests and completing the handshake. One of the most cool things that you can do with a node is study how it's working from the inside, and for that I added this debugging feature. So if you start the node like this, for the debugging feature, you need Rust flags, Tokio unstable, because it uses Tokio tracing, which is really heavy. And even when we started, you will see that the memory footprint will jump from 150 megabytes to 1 gigabyte. So let's start first of all. Let's start without this, without that flag. So as expected, it failed because it needs this flag. Cargo node, features, debugging. So now it started successfully. And as you can see, the node is working. The peers are connecting gradually. So it is fetching the block heights and versions. So now it handshaked with everybody. The memory footprint grew a bit, but let me show you something really cool. You can open in another terminal Tokio Console, and Tokio Console will connect to the Tokio runtime to the tracing of the node that is running. And from this window, we have the insight into inner workings of the runtime and all scheduled tasks to, for example, check what resources tasks are using and how they are behaving and if everything is expected. You can press here R and switch to the resources, and they include like locks, semaphores, the different interval tickers. Let me switch back to tasks. Let me also show you the replay, because the right now this is the real communication with 30 peers. The data in is about 400 kilobytes, not more than that. And if we run the replay doesn't have the throttle on the number of packets it feeds into the node, so it will just dump all of the packets as fast as it can, and will also observe that the number of tasks will grow. The parallel the messages processed in parallel. So let me stop this and also add the replay. UDP replay equals we are still running this with debugging. It is absolutely fine, and we can even do Rust log equals info, because during the replay the node is not connected to the internet, and it will try to send information back, send messages, but they will be discarded unless variable, which will dump whatever node sends into a different file. So let's start the node like this. As you can see here, it's trying to not with debugging and the log level, which is info. The node also shows once every few seconds the current memory allocation, the RSS, the allocated, and the active memory. So let me show how it looks in the dashboard. So in the dashboard, the data in grew a lot, and you can see here 65, 30 tasks, 34. So the node is processing a lot more data, and the CPU usage grew to 56%, which means that at least 5 out of 10 cores are really used to their max. And the peers table doesn't show any connected peers because peers are not responding. This is just the replay, and whatever node sends just gets discarded. So this was the short update on the progress of the dashboard and the Rust node. Thank you.